Okay, so the top of this formula sheet, these identities are not on the reference page that you guys are going to get when you do your challenge exam, which will be sometime in May probably. So this group are ones that you're going to need to memorize. So we are going to have a memorization quiz over them probably beginning of next week. I feel like you already know these, because you know that the cosecant is the reciprocal of the sine and all that, right? Okay. These two, the quotient identities, I think you'll know by the end of the day today. They're pretty easy to remember. And then the cofunction identities also aren't too bad. So sine and cosine are cofunctions, because if you take sine, you put co in front of it, it's cosine. That makes them cofunctions. So that means cosecant and secant are cofunctions, and tangent and cotangent are cofunctions. So if you have the sine of this pi over 2 minus t, it's always the same as the cosine of t. So I feel like with a little studying, you can have those memorized. And what I'll do is I'll give you this side, and you have to fill in the blank with that side. So I think you can just remember cofunction. And then even and odd aren't terrible. So what you need to know about even and odd is there are 2 even functions. Out of the trig functions, 2 are even, 4 are odd. So looking at them, which 2 do you think are even? Which 2 look different than the other 4? Cosine and secant are even. So on an even function, if you put a negative angle in, then it's the same as the positive. So that means the cosine of negative 30 degrees is exactly the same as cosine of positive 30 degrees. And then the odd functions, when you put a negative angle in, it's just the opposite of what that is of the positive angle. So the sine of negative 30 degrees is negative sine of positive 30 degrees. All right? So start studying. You're going to have to be able to fill in the blanks, and I'll switch up the order. But I'll give you the subtitles. I'll say even, odd, and then I'll have 6 of those in a shuffled up order. Okay. You can do it. Trust me. All right. And then these are all on the challenge exam formula sheet. So they are much more difficult to learn. So you do not have to memorize any of these. And then for the first few days, we're only going to be from Pythagorean theorem identities up. So Pythagorean identities up. It's all we're going to talk about for at least 3 or 4 days, right? The bottom ones we'll wait on. Okay, so what we're going to do is we're going to be using those formulas and identities to simplify trigonometric expressions. So we're just going to take them and just use them to write it in a simpler way. And so the first example is matching. So I have some choices, these 4 are going to end up being one of those 4 answers. So let's just start with 1. If you guys looked at this one, where would you look on your formula sheet? Where would you look on your formula sheet? Cofunction. So if anytime you see this, pi over 2 minus x, or pi over 2 minus theta, or pi over 2 minus t, you're going to look at the cofunction identities. Okay, so looking at your sheet, what does sine of pi over 2 minus x equal? Cosine of x. So make sure you use the same variable. The variable, sometimes it's x, sometimes it's theta. I tried to make it match what's on your formula sheet, but we could use any variable there. All right, and then the sine of x is just going to stay in the denominator. All right, and then you guys look at your identity sheet for something that maybe looks like cosine over sine. Quotient identity, good. Yes. So if we have the sine of a variable over the cosine of a variable over the sine of that same variable, it's just cotangent of that variable. So this ends up being, yes, come on, cotangent of x, which is c. All right. So you're going to have to think in a different way. It's kind of like a problem-solving situation or a puzzle-solving situation. All right, let's look at the next one. Now, what's difficult for people at the beginning is not knowing where to start. And then when there's not choices that you're matching, the other thing that's difficult is not knowing when to stop. And so for a lot of students who are advanced level thinkers and advanced producers, I guess, who do really well, they don't want to start it until they know how it's going to finish. Like they don't want to do something and it be wrong. And you're just going to have to let that go. So if you do the wrong thing, it's okay. You just try something else. So just kind of have to let that go. So there's lots and lots of things we can change tangent and cotangent too. So my advice at the beginning is just change one thing. So just decide that you're going to change tangent or decide that you're going to change cotangent. And it's fine, whatever you choose. So what do y'all want to do?
I have a question.
Okay.
Since they're inverses.
Wait. What do you want to do? Tangent. Okay. So let's look at what we can change tangent to. So we can use a reciprocal identity and change tangent to 1 over cotangent, or we could use a quotient identity and change it to sine over cosine. So looking at what you're going to multiply it by, what would it be smarter, do you think? Reciprocal. So if we change tangent to its reciprocal, which is 1 over cotangent, and we're going to multiply that by cotangent of x, what should that give you? 1. And 1 is an answer choice, right? 1 is A. And that's it. Now, does it make sense to you that you multiply reciprocals and you get 1? Yes, every time you multiply reciprocals, any kind of reciprocals, you get 1. And so the more of these you do, when you see tangent times cotangent, you're going to say 1. If you see sine times cosecant, you're going to say 1. Because when you multiply reciprocals, you get 1. All right, so I'm going to warn you. Number 3 is a pretty big step up from the one we just did. All right, so whenever you guys see like a trig ratio squared plus 1 or minus 1, where you want to look are these Pythagorean identities. All right, so we have 3 of them to choose from. Now, what we have here was cosecant squared of x minus 1. So I don't have an identity that exactly says that, but do I have one that has a cosecant squared? Yes, so we're going to use this one. So I'm going to come down and write it over on the side. So 1 plus cotangent squared of t equals cosecant squared of t. So I want to kind of rearrange it, and that's okay. I'm going to rearrange it so it looks like this. So I want to move the 1 on the same side as the cosecant squared. All right, and so that's just like an alternate version of that same identity, and that's perfectly fine. So now, in the place of cosecant squared of x minus 1, I'm just going to replace that with cotangent squared of x. Now, in the notes, I am writing down the identities we're using. You don't have to do that when you're doing that on your own. It's just in case you wanted to look back and see what we were thinking. Okay, so those Pythagorean identities, they have to be square. Like this has to be sine squared, cosine squared. Like you can't have like sine cubed, cosine cubed, or sine to the fourth, cosine to the fourth, and use those identities. They have to be squared. However, all of these up here, you can have powers. So like if you had sine cubed, you could rewrite that as 1 over cosecant cubed. That's fine. If you have tangent squared of t, you can write that as sine squared over cosine squared. Those are perfectly fine to change the powers. So that's what we're going to do on this one. So we have cotangent squared. We're going to use a quotient identity. And we're going to rewrite that numerator. But we're going to leave cosine squared in the denominator. So again, don't try to change too many things at one time. All right, so in the place of cotangent squared of x, we're going to write that as cosine squared of x over sine squared of x. All right. And now we're not going to use an identity. We are just going to use algebra or rules for dividing fractions. So how do you divide fractions? Right. Okay, so we're going to leave cosine squared of x over sine squared of x alone. And we're going to multiply it by the reciprocal of cosine squared of x. All right, so what can we do? Cancel out the cosine squared. And that leaves you with 1 over sine squared of x. Now that is not an answer choice. But does it equal one of the answer choices?
Yes.
It equals cosecant squared of x. So that is D. All right, so we had to use, bless you. I'll add this in here. We had to use 3 identities and some algebra to do that problem. All right, any questions? Okay, now we already know what this is going to be because the only choice we have left is choice B. But we don't have any identities really that deal with to the 4th power. So we're going to do something different on this one. We're actually going to factor it. Now the whole back side of this note sheet is on factoring, so you're going to get lots of practice today with that. So we're going to factor using difference of squares. Now we haven't factored really in a while. Like this whole semester, I don't think we factored one time, but we are going to now. And it's going to be kind of weird because we're going to be factoring with trig expressions, but the rules are the same. So when we factor using difference of squares, you find each square root, like I wrote right here, and then you put one with a plus and one with a minus. So what's the square root of sine to the 4th of x? Sine squared of x. All right, and we'll do one with a plus and one with a minus, and then the square root of cosine to the 4th is also the square root of cosine to the 4th is also cosine squared of x. All right, so that's still not one of the answer choices. Do you guys see an identity we can use? Pythagorean identity. Very good. So sine squared of x plus cosine squared of x is going to be 1. So then when you multiply that by 1, you get choice B. And that's it.
that one?
It's this Pythagorean identity right here.
Okay.
All right. Any other question? Okay, so we have 5 more on the back that we are going to factor. So, like I said before, for when you guys first start this, it's really hard to know where to start. So this is nice because it already tells you you're going to factor. So that's where we're going to start. Now, this numerator, sine of x plus cosine of x, that won't factor. Like, it'd be like having x plus y or x plus 2 and me telling you to factor it. So the numerator is not going to factor. But what about the denominator? Yeah, it's going to be difference of squares again. So we find each square root and put one with a plus and one with a minus. All right. And then I talked to you guys about marriage a long time ago. And what I told you was that like the addition and subtraction binds them together in marriage. And then they have to die when there's another couple just like them. Y'all remember that? It's
Yes.
kind of weird. All right. So there, the sine of x plus cosine of x does have to die. And if everything gets canceled out of the numerator, what's up there? 1. And then this is it. So you could try to do some things to make that more simple, but that is all we can do. That's the answer. All right. When we look at B, it is a difference of squares also, but if we factor it that way first, we won't be able to simplify it like we can. So instead, this one, first thing we're going to do is factor out a common factor. So when we are deciding the common factor, you're going to look at what's in front of the minus and what's after the minus. What do they have in common? Cosine squared of x. So that's what we're going to factor out. So when you factor out a common factor, you put it outside a set of parentheses, and then you divide by it. So when I divide this by it, what are you going to be left with? Cosecant squared of x. Good. And then when I factor it out of itself, you're left with minus 1. Okay. So again, when you guys see a squared trig ratio and a plus 1 or a minus 1, you probably can do a Pythagorean identity. And this is that one that it just keeps coming up. So we just talked about it here. So an alternate way to write that identity is that the cotangent squared of x is cosecant squared of x minus 1. And so that is what this is. And that really is as simple or as simplified as we can make this one. We could try to do things, but it actually just make it more complicated in this case. Okay. All right. Oh, we might write, you can make a note if you want to. That was Pythagorean identity. All right. What do we do when there's 4 terms and you're supposed to factor?
Split it.
By grouping.
Grouping. Good. All All right, so we do split it in half, and then we're going to factor a common factor out of each group. Now, it is kind of weird that your common factors are trig ratios, but it all works the same way. Okay, and then just a reminder, whatever sign is here does have to go here, so it's going to be a plus. What do you do if there's not a common factor? 1. All right, this worked out perfectly. So for us to be able to factor by grouping, when we do that first step, these do have to be the same, and they are. So what we factored out is one of your factors, and what was left over is the other factor. All right. And then again, we have a squared term and a 1, so probably a Pythagorean identity, and it is. It's actually the way it's written this time. So cotangent squared of x plus 1 is the same thing as cosecant squared of x. So we'll just replace it with there we go. All right, and that's your answer. All right. Any questions? This next one is kind of weird. So it's a trinomial. So it feels like you're going to just do your two sets of parentheses. And then we would do cotangent times cotangent to get cotangent squared. But then somehow we're supposed to get cosecant. And the way this is right now, that won't happen. So we're going to have to rewrite with only one trig ratio. So we have to decide if we're going to change cotangent to cosecant or cosecant to cotangent. So if you look at your identities, just regular old cotangent, we can't use the Pythagorean identity if it's not squared. It just cannot happen. So if you're looking up here, is there a way you can write cosecant as cotangent? Do you see any of these that have cosecant and cotangent in it? Mm-mm. So that it just can't happen. We can't do it that way. But once we have cotangent squared, we can write that. We can write cosecant squared at least. So that's what we'll do. All right, now we've used this identity a bunch of times. I'm just going to write it one more time. So originally it's written this way. All right, but we don't have cotangent squared plus 1. We just have cotangent. So I'm going to move the 1 over. So that means that anytime I have cotangent squared of x, I can write it as cosecant squared of x minus 1. Every time, if I want to, I can do that. So in the place of cotangent squared, I'm going to write cosecant squared of x plus 1 minus 1. Did I say minus 1? I think I said plus 1. All right, and then everything else I'm just going to bring over. All right. So then I am going to kind of combine my like terms. The only like terms I have are -1 minus 1. And then I'm going to factor this just like a normal trinomial. So what I put here and here needs to give me cosecant squared of x. So what do y'all think? Cosecant and cosecant. All right. And then what does this minus tell you about your signs in the factors? There you go. They're different. One's a plus, one's a minus. Okay. And then what I put here and here has to multiply to give you 2. The only options are 2 and 1. So you have to decide to get this cosecant of x. Do I want a positive 2 or do I want a negative 2? And if it's a positive cosecant, we're going to want a positive 2 and a negative 1, the bigger number. All right. And that's it. Okay, one more. I know this is a lot of examples for one day. So this one is another trinomial. It's great because they're already the same. They're only cotangents, so we're good. We can just go ahead and factor it. This one has a lot more options though. So to get 6 cotangent squared of x, I can do 2 cotangent of x and 3 cotangent of x, or 6 and 1. What would y'all guess? Because it's just guessing. Would you? You could. It's fine. You definitely could. It's just not going to work. It's okay. So if you do it wrong, it's okay. You just start over with something else. All right. What does this plus tell you? Same. And they're both minuses. Okay. Now you kind of play around with the 5 and the 1. So when you do this, you're going to end up with negative 13 cotangent of x. What do y'all think?
So 5 is on the first one. No.
Let's see. We do it that way. That would be.
Wait, I'm sorry.
No, it's okay.
You literally said, like, because you do the things, you said negative 13.
Yeah. So it's going to be, it's okay. 5 and 1. So that's going to be negative 3 minus 10. That will give you your negative 13. And again, if you mess up, it's okay. That's really part of it, is just learning from your mistakes. And don't forget, you can do hard things.
Do I need to write that down?
Yes. Write it down. Remind yourself.
I want to put this in my memos and like have it as like a widget on my phone. I'm gonna take a picture real quick.
Okay.
So it's my inspirational quote. It's gonna be what I